Okay, for lesson 16, first of all, we want to start off by reviewing some simplifying of complex fractions. So like if I have b over d, and I divide that by 4 over c, you know that the rule is that you do b over d times the reciprocal of the bottom. So you would get bc over 4d. Okay, so if you have 6 over x over 7, then you would have 6 times 7 over x. So that would be 42 over x. Okay, so if you have like a plus d over 4, and you divide that by b plus c over 4. Now, of course, we're going to do the same thing we just did, right? We're going to take the top and multiply it by the reciprocal of the bottom. When I flip this 4 is going to be on the top, and this is going to be on the bottom. So anytime, and of course they're going to cancel. Anytime that you see a fraction divided by a fraction, and the two denominators are the same, you know they're going to cancel. So this is just simply a plus d over b plus c. Okay, so now that we've reviewed that, let's do the same rule to a little bit more complex fractions. So if I have x over a plus m, and that's being divided by b plus c over d. So this is the bottom of that fraction, and then we have this big fraction here, and that's part of a bigger fraction. What we have to do is we have to concentrate down here first. So we've got to simplify this part. It needs to have a common denominator. If I get a common denominator there, it's going to be d. So it's going to be bd plus c at the top. Now I'm going to take this and multiply the reciprocal of this to the top. Remember, this is the top of the fraction, this is the bottom. So I'm going to have md, so I'm going to take m and multiply by the reciprocal of this. So I'm going to end up with md over bd plus c. Okay, now what have I just done? Well, here I got the common denominator. Okay, here I flipped it and multiplied it. Okay, which is what step 2 down here is talking about. The next thing I'm going to do now is I've got a fraction, a complex fraction again. I got to get another common denominator now. The common denominator is going to be bd plus c. So what does that mean? Well, that means I got to multiply a times that. No, that means distributive property. And for this one, it's just going to stay the same. Then I'm going to have x times the reciprocal of this. So it's going to be x times the reciprocal of this. I'm going to write this out for you because it gets more crazy looking here. Well, when I multiply this times x, it's just going to be distributive property. Now, of course, we always want to look and see if we can reduce it. You know, I can factor an x out of the top, but I can't factor an x out of all of those in the bottom. There's nothing common in all 3 terms in the bottom for me to factor out, so there's nothing I can do to reduce this. So this is just in its simplified form. Okay, let's go to the other page, next page, the back page, or second page if you downloaded it. So if I want to try and simplify this, I need to get a common denominator for the top to start. The common denominator is going to be a squared x. Now, when I get the common denominator, then I'm going to have to multiply both of these by x. So it's going to be m squared x for that one. For this one, I'd have to multiply both of these by a squared. So it's going to be 7a squared y, and that's the top. I need to get a common denominator on the bottom. So it's a squared x. To get a squared x here, I have to multiply it by a. So multiply that by a. To get a squared x here, I multiply by x and multiply that by x. Okay. Now, What I want to do is I want to take the top and multiply it by the reciprocal of the bottom. But hey, look, the denominators are the same. Remember the little trick I showed you before? We don't have to go through all that. We know they're going to cancel out. So I know that this is going to simplify to m squared x plus 7a squared y over ap squared minus 3x. Now you can't always do that. They have to be exactly the same. Okay, so that one's done. So let's try this one now. So we have a plus, actually isn't this the same one I just did? Well, it sure is. We don't need to do this again. But you can try it on your own if you want to. That would be a good thing. Okay?